The following is a video going over the common errors in RIP3. Problem 1a, we would subtract 3 from both sides. 5 times the absolute value of 2x plus 3 is greater than negative 20. Then divide by negative 5. Absolute value of 2x plus 3 is less than 4. Most people did pretty well up until here. Some people would forget to flip the inequality sign when we divide by a negative. Then we have the algebraic step of breaking the absolute value into two cases. Almost everybody did a great job of breaking this into two cases after they got the absolute value all by itself. Then we subtract 1 and divide by 2, so x is less than 1/2. Subtract 3, divide by 2, and then subtract 3, divide by 2 here, and get x is greater than negative 7/2. Most people got to here. Some people made some mistakes algebraically in certain spots, changing this to a minus sign or something like that. Most people did a good job. A lot of people stopped here and just left it like this and assumed that we know what that means. We don't actually know what this means. X less than 1/2 and x greater than negative 7/2 could have an or in between or an and in between. And if you don't specify and you leave it like this, then we're left to guess as to whether what the answer is. One of them, if the word or is actually used, this would be all real numbers as potential answers. The word or should not be used in this case. The word or would be used in a case where we have something like this as a problem. But we don't even really spend a whole lot of time on and or. We ask you to analyze the situation and figure it out based on the graph and using distance. And if a distance is less than 4, we have a situation that looks something like this, where everything on the interior of this, so this distance, actually the radius is 2, because we would take this and divide by that number to figure out the distance from the center or the radius. But this is kind of what the graph looks like. A lot of people didn't graph it, and it doesn't say you have to, but graphing it kind of helps you understand how to write the answer. So if you just leave it like this with no and or, you're probably not going to get full credit. Instead, you probably would want to write something in interval notation, or you can write it in inequality notation because it doesn't specify. But either of these would be an acceptable way of writing the answer. Now, some people took this and then said something like negative infinity to negative 7/2 union 1/2 to infinity. And that is incorrect, because that would represent the graph that goes off like this, from negative infinity to negative 7/2 and 1/2 to infinity. So just be careful on how you represent your answer. Representing your answer is very important. The integers are counting numbers, positive and negative. So positive and negative counting numbers are the integers. So in this case, we only can have the answers that are between these two numbers that are counting numbers, positive, negative, and 0. So that'd be -3, -2, -1, and 0. Those would be the counting answers that we would be able to have. A lot of people included -4 and +1, even though those are outside of our bounds. And a lot of people also wrote the answer as if it were interval notation, like -3 to 0. Well, that would also include every value that isn't an integer in between here. An interval means that we're basically taking all of the values that go along there. So this is an interval, and this would be just listing possible answers, listing points. So when you're dealing with integers, that's probably the way to go. Okay, so when we have, it's very important that we understand how to write our answer. So problem 2a, graph g of x, most people did very well. So write 1 up to slope-ish. I know slope is not the best word to use, so vertical shift of 3. So that would be our graph. And then a lot of people did a very good job of figuring out how to graph h by replacing g in here. So they would say something like -1/2, and then 3 absolute value of x minus 4 minus 1 plus 2, and doing a lot of work here. Some people didn't really understand how to deal with the -1/2. Like if we're doing -1/2 times g, so the -1/2 has to distribute to both of these parts, not to just this part and then add 2 later. So you can distribute this thing and you end up with -3/2 absolute value of x minus 5, and then minus 1, because -1/2 times 2 is -1. So this is h of x. So if you want to graph h of x, this is a great way of doing it. Right 5, down 1, and then 3/2 is our slope-ish, and we're going down. A lot of people did that, and they did a great job. Some people tried to do this and made algebra mistakes, but this would be how you go about doing it. The -5 came from -4 minus 1. But that has nothing to do with what this question is actually asking for. This is asking how to transform h of x compared to g of x in words. And so what we would say is something to the effect of g of x is stretched vertically by 1/2, multiple of 1/2, reflected over the x-axis, and horizontally translated right 4. That's what happens to g of x. What a lot of us were doing was we were describing h of x in terms of absolute value of x. So we would say things like reflected a stretch of 3/2, right 5, down 1, or something like that. And that is true if you're comparing h of x to the absolute value of x, but that's not what the question was saying. We wanted to compare h of x to g of x, and we already had g of x. Now, one of the crazy things is if you take this equation here, you can actually get the graph of h without getting an equation in terms of absolute value. So I will show you right now. Take this point, move it to the right 4. See, right 4. Now what's happening is I've already lined up my vertex with this point. Now I have to multiply this value by -1/2. Well, if I multiply it by -1/2, in terms of the y's, 2 times -1/2 is -1. I have now relocated my vertex in the exact spot that I need to. Let's take another point. For example, this one. Let's move it to the right 4. 1, 2, 3, 4. Then what I can do is I can take this point and I can multiply it by -1/2. So if I take this point and multiply it by -1/2, I was at 5. I'm now at -2.5, which is miraculously on the line. If I take this point and I move it to the right 4, and then I multiply it by 1/2, I was at 8. I'm now at -4, and that is also on the graph. So if all I do is exactly what I describe from G to H, I will end up getting the exact same graph that I wanted.